Hello, everybody. We are going to get started in a minute, just letting folks trickle in. Welcome, and thank you so much for joining. We'll start in 1 minute. All right, so welcome all. Thank you so much for joining our fall transmission webinar hosted by the Interplanetary Initiative here at Arizona State University. I am Jessica Rousset. I'm the director of the initiative. There you go, that's me. And again, welcome. We're really excited to spend the next hour with you all. Today, we're going to be focusing in on two areas. Sorry, if we could go back a slide. Two areas of our programming. We're going to be telling you about a lot of our learning programs. And this is an area of our work that's really been growing. And so we're excited to give you a lot of updates on our educational programs and learning programs and all the ways in which our students can engage with us. So you'll hear from staff and you'll hear from students about all of that. And then after that, we'll be showcasing all the work happening in the Interplanetary Laboratory. This is a lab that's located here on our Tempe campus. It's been going for about 3 years as a shared resource for the development of space hardware. It's a place where students and faculty and startups and established companies can all come together and collaborate to launch new projects. So really excited to showcase a lot of the work that lab has been enabling. And you'll hear from staff and students that are making all of that happen as well today. So next slide now. Thank you, Shireen. Before we get started, I just want to give a huge shout out to our Vice President for the Interplanetary Initiative, Dr. Lindy Elkin-Stanton, who is the lead scientist on the mission to Psyche, which saw a flawless launch on the auspicious day of Friday the 13th, 2023. And we couldn't be more thrilled for her and just all of the hundreds of people and hours and days that went into making that a success. And the fact that the early journey of Psyche to the asteroid is going very smoothly as well. All the instrumentation is working as planned. And if you want to keep track of its progress as it reaches Mars and then the asteroid, here are two resources that you might want to bookmark. So go Psyche, and again, huge congratulations to Lindy and team. Next slide. Okay, so we're all familiar with the drill. This is a webinar format. So unfortunately, while we don't see you, we want to hear from you. Please use the chat and the Q&A function. Let us know where you're dialing in from. I see you've all started doing that, and that is fantastic. We'll be sending you a recording, as always. We'll be soliciting your feedback, as always. We want to hear from you and your suggestions on how we can make our time together even more valuable. And yes, put your questions in as well. We'll answer them as we go along, but for sure, we'll address them at the top of the hour. And then lastly, if you haven't downloaded the Sun Devil Reward app, you might want to do that because your attendance today will earn you pitchforks, and you can exchange those pitchforks for ASU merch. And who doesn't love merch? So next slide, please. So these are just a few programs that we're going to highlight for you today, but there's a lot of other activities and programs and exciting projects that we'd like to keep you appraised of. And the best way to do that is just to sign up for our monthly newsletter. But if you do want to reach out to us for any other reason, you can do so at interplanetary@asu.edu. Next slide. So for today, I'm just going to spend a little time welcoming some of our new team members, and then we're going to dive right in. We're going to go into our learning programs and our laboratory activities and projects. Next slide. And so here are our new team members. Shireen Dooling is a new project manager for engagement. So she's going to be working closely with all of us, but Tara and Struck in particular. And Shireen brings a unique blend of skills and passions to our team. She holds a Bachelor's of Science in Graphic Design from the ASU Herberger Design School, which completed in 2013. And in addition to this design background, she recently earned a second Bachelor of Science in Astrophysics, graduating just this past May. So really brings incredible skill sets to our team, and we're thrilled and lucky to have Shireen. The next person I want to highlight for you all is Jack Traphagen. And yes, he goes by Jack and not John. He's our newest fellow. So this is the second fellowship that we offer through the Interplanetary Initiative. This time we partnered up with our School for Philosophical History and Religious Studies, Shippers. And Jack brings incredible expertise to our group. He's an anthropologist. He's a scholar of Japan. And he's going to be focusing this year on exploring how JAXA, the Japanese space agency, is pursuing programs and narratives around space exploration that are influenced by Japanese religious and cultural ideas. His findings are going to be included in an edited volume, which is titled tentatively Religion and Space Exploration in Cross-Cultural Perspective. And he's also going to be hosting a cross-cultural symposium at our facility in Washington, D.C. And that's going to be in the spring. So if you're interested in learning more about this, we will be inviting Jack to come and talk about his work in a future webinar, but also sign up for our newsletter, and you'll learn more about all of this great work. And last but not least, I'd like to introduce and welcome Shanmugam Rangaswamy Murugan, and he is a master's student in mechanical engineering. So he's going to be supporting Chase Castle, who's our portfolio manager, in helping with a lot of our pilot projects that we seed fund and that we showcase also through at a different time, but at a webinar, which we invite you to, of course, tune in for. And he's also been volunteering in the Interplanetary Lab. And so welcome, Shanmugam. We're very excited to have you on board as well. So those are our new crew members. And now let's move on to a couple announcements. So before we're going to get started just in a moment, but I do want to highlight an event that we're going to be hosting March 28th, 2024. This is building upon the inaugural Arizona Space Summit that we hosted early April 2023. This was the first summit where we brought together leaders from academia, government, and industry, both based in Arizona and from outside of Arizona, to engage in a conversation and explore ways in which we can better coordinate our efforts across sectors in the state to support the growth of the commercial space sector. Next slide, please. This initial summit resulted in a report. We highly encourage you all to read the report. It highlights the discussions that took place at the summit and a few recommendations for, again, advancing and elevating the industry here across the state. Check out the website for more information, and please look out for an invitation to attend our second summit. And so now I'd like to introduce our Senior Director for Learning, Catherine McConaughey, who is going to tell us about all the ways in which we at Interplanetary are advancing learning through innovation. Thank you, Catherine.
Awesome. Hello, everyone. Good afternoon. I am very excited. If we can go to the next slide, Shireen. Oh, yep. There's me. It's very nice to be here today with you all. My name is Catherine McConaughey. I'm the Senior Director of Learning for Interplanetary Initiative, and I oversee our portfolio of educational programs and student engagement efforts. And I'm really excited today to tell you, especially our current ASU students who are in the audience, all the different ways that you can get involved with the Interplanetary Initiative. So to start, it is spring course registration season, and we wanted to give you a little preview of some of the exciting courses that we're going to be offering this spring. First up is a course that we offer regularly. It's our Inquiry Course series. This is a fantastic place to start if you're interested in sort of dipping your toe into the Interplanetary Initiative. This is a course where students work together very collaboratively to make progress on a big question related to the future of humanity and space exploration. And every semester, we have students tackling a different big question, working with a variety of different instructors. And this spring, we're going to have Professor David Williams from the School of Earth and Space Exploration teaching our immersion course. And his topic for the semester is going to be focused on the Star Trek media franchise. Students are going to be asking, how can the Star Trek media franchise inform our understanding of what it will be like for our future of living and working in space. And this is going to be a really fun course to participate in, and students get the chance to ask and answer their own questions around this big theme. We'll also offer this course online um, with a different theme, and that will be taught by our Interplanetary Initiative Associate Director, Evgenia Shkolnik. Now I'm going to toss it over to my colleague, Eric, to tell you a little bit about his courses that are happening this spring.
Hello. So the first course that I'd like to talk about is IPI 341 Design. This is the second course in a three-part series on designing and making, which is part of the technological leadership degree. It's not limited to students in the technological leadership degree program. And if you are a student with a major within the college, you can get Gen Ed Science and Society credit. In this course, students are going to be physically making objects, small technologies. We're going to start covering CAD modeling, 3D printing, and then eventually moving into building out moving parts with the end goal of creating a small CubeSat with deployable wings. The second class that I'd like to talk about is a new course that sort of grows off of some of the work that we did with the Space Hack for Sustainability hackathon last spring. This is only for immersion students, unfortunately. But this course is going to sort of look into the various historical, scientific, cultural, social contexts that goes into why wildfires are such a huge problem right now, and then delve into how space technologies have been used to sort of prevent, detect, and mitigate those wildfires. And then students are going to have the opportunity to take a historical wildfire and do sort of a what if scenario, looking at if we had certain technologies available, how would that have impacted the devastation caused by the wildfire. So if you are interested in taking either of these courses and have questions, feel free to reach out to me or Cassandra or Catherine. And with that, I will pass it to Lance.
Hello, I'm Lance Garavi, professor of theater in the School of Music, Dance, and Theater, and associate director of the Interplanetary Initiative, where I lead lots of projects. And every spring, I teach a class with Dr. Patrick Young, a theoretical astrophysicist and astrobiologist in the School of Earth and Space Exploration. The class is called Astrobiological Arts. So this is the Interplanetary Initiative. We love big questions and also snacks. Big questions and snacks, those are the things we love. And one of the biggest questions out there is, are we alone? Are we alone in the universe? And this is a course that's built around that question. It is it is a mix of, as the title implies, astrobiology and arts. Students pursue research into astrobiology, which is the study of life in the universe, and then they create art based on what they discover. And they can create any art in any medium they like, whether it's painting or sculpture or dance or music or poetry or photography, anything, any art form you like. We offer this. This is open to any in-person ASU student, um, undergraduate or graduate. They don't have to be art students. They don't have to be science students. No previous art or science experience required. We have everything. Like last spring, we had a first-year freshman and a last semester PhD student who literally defended during the semester. And so they all come up with big questions around life in the universe, and then they form research groups based on what questions they're really interested in. And uh, let me just tell you, this is hands down the funnest class I have ever been involved with in my entire life. We regularly have faculty enrolling in this class because it is so fun. We've had staff enroll in the class because it's so fun. If I were to say my favorite thing about the class, uh, uh, oh God, it's either like all the amazing things I learned, or I learn every semester, or all of the amazing art they create. But I think it's this. Like you would think that, oh, I bet the science students are like doing, showing up the art people. We have about a good 50-50 mix of art students and science students. And you would think there'd be a big difference there that you could see. One of my favorite things is that after a couple of weeks, you look at the research the students are doing, you can't tell who the science majors are from the art majors. After a couple of weeks, you look at the art they're creating, you can't tell the difference between the art students and the science students. So astrobiological arts, big questions, big creativity. It's a terrific class and I love it. And who do I shoot it over to?
That would be me. Thank you so much, Lance, and thank you,
Yeah.
Eric. We have a amazing list of classes for you all in spring, so I hope some of you will join us. I did want to call out that all of these classes are part of our technological leadership programs, both our major and our minor, but I thought in particular, folks might want to be aware of the fact that we do offer a minor, and it's a great complement to any major that you might already have declared, to enhance what you're learning there with key skills in interdisciplinary leadership, technical design thinking, interdisciplinary research, technical design thinking, and collaborative leadership. It's 18 credits, and if you participate in a class with us this spring, you might consider looking at the other classes that are there and adding that to your time here at ASU. So next, I also wanted to share another way that you can get involved with Interplanetary, which is by becoming a student research scholar and working on some of our research projects. So we offer this program, the Interplanetary Student Research Scholars Program, that is open to students from all majors and programs to apply. It's a great way for you to get involved as a student working on Interplanetary Initiative research programs. And applications for the spring 2024 semester for these research positions will open in early November, so coming up soon. And the best way to get notified about when that application opens is to subscribe to our Interplanetary Initiative newsletter. This fall, we have a wonderful cohort of undergraduate students who are participating in this program. We have 18 students, 10 online, 8 immersion. They represent 12 different majors and they're working across 7 of our research programs. And we have 2 of them here today to tell you a little bit more about their experience and what they're working on. So first, I'm going to hand it over to Kennedy to tell you a little bit more about herself and her research this semester.
Well, hello everyone. I'm so excited to be here. My name is Kennedy Gordine. I am a junior here at ASU studying sustainability with a concentration in international development, minoring in urban planning. And I am a fall 2023 II Student Research Scholar. My project is the DEIA Service Model, which is a project that's focused on taking insights on non-performative mechanisms that both accelerate and enable creating a diverse and equitable workforce through the space sector and turning it into action. Through my research, I'm working on creating a comprehensive business service model that outlines actionable steps for space industry organizations to enhance their DEIA efforts. We're defining what's possible every day in the space sector. So why not create an inclusive, diverse, equitable, and accessible environment for everyone?
Great. Thank you so much, Kennedy. And next, we have Mateo here to tell you a little bit about the project that he's been working on.
Hey everyone, my name is Mateo. I received a bachelor's in philosophy all the way back in 2012. So I've recently transferred to Arizona, or Arizona Online program for astronomical and planetary sciences. I believe I'm a junior because I have about a year left in the program. I have no prior research experience, and the project that I was working on, or that I'm currently working on, is exploring century scale space engagement. Shreen, could we go to the next slide, please? What this program is it is not a standard scientific research program. What this program is doing is taking an existing research paper written by our mentors, Kevin Lewis and Anna Doyle, and we're looking at the big question of how to increase the feasibility and effectiveness of projects that take somewhere between 50 years, 100 years to 200 years to complete. And the main outlook that we're looking at is how to increase public interaction and public, what we call interestedness in space exploration. We're looking at everything from intellectual property that has existed for over 100 years. We're looking at marketing, advertising techniques. We're looking at sociological, historical, and most importantly, psychological perspectives of how to get people interested. What I really liked about this project is that I actually don't know the majors of or the focuses of any of my research compatriots. I don't know what they're working on, but what they do is they bring all their own individual work to this project, their own individual perspective, and that's what this needs. It needs a collective of individuals with different perspectives. My first personal contribution was space interest survey development. So to find out where we are, to find out if people are interested, how they're interested, and at all different levels. Children, students, adults, professionals in the astronomical societies, they're all going to be different and they're all going to have different interests. So we're going to find out where the interest is and where we need to go. Our final project will be helping to develop intellectual property to help increase interestedness. And this can be anything from new exhibits to pop-up shops to characters for television shows. We're taking a big question and going at the research from a bunch of different angles. And it's been a great experience. It's opened up a bunch of different avenues of research that I probably would have never gone into. And it's been very helpful for me. And I'm really excited to see, hopefully this same class continue.
Wonderful. Thank you so much, Mateo. It's great to have both you and Kennedy part of our cohort this fall. So next, I want to tell you all about another great way that you can get involved with space at ASU, which is by becoming a Space at ASU Student Ambassador, a different program that we offer. And we have another wonderful student here today to tell you a little bit more about the program and his role. So I'm going to hand it over to Taylor.
Hey everyone, I'm Taylor. I'm studying human systems engineering at the Polytechnic campus, and I recently I'm in the second inaugural class of the ASU Space Ambassadors. So essentially, in my major, I'm studying applied psychology and cognitive science, and how that relates to engineering solutions for people now and in the future. And it really has to deal with a lot with user-centered and human-centered design. which ties into my design studies minor. Next slide. So the space at ASU, or the space ambassadorship that ASU is offering, essentially is a professional development leadership program that's looking to have us ambassadors network within the ASU's several space facilities and resources, and then also the industry networks, industry leaders, and there's several events that throughout the semester that we will be volunteering for, and helping provide support to further the Interplanetary's mission at tackling these big questions in space. For example, I was earlier this year, I attended the Space Futures Live, which had several visiting scholars come and discuss big ideas for what the next steps would be if humanity becomes an interplanetary society. And there is, most of us are upperclassmen in this program, but it's very interdisciplinary. We're all committed to further understanding the emerging commercial space sector, and we are continuing to do that by our participation in this program. Thank you.
Wonderful. Thank you, Taylor. Yeah, and the wonderful thing about this ambassador program is it is a program that is part of ASU Space. So all of the different entities across the university who are working in space, so not just the Interplanetary Initiative, but these students are representing all of the stakeholders at the university who are carrying our mission forward. And this is a wonderful opportunity for students to volunteer, to give back to the community, to help other students at ASU get involved with space, but also to develop their own leadership skills, network, and make lots of connections within the space industry. So we open applications for our next cohort sometime in the spring. And again, one of the best ways to find out about that would be to subscribe to our newsletter. So thank you, Taylor. And then last but not least, I want to tell you about one outreach related program that we have, which is called Open Citizen. This is a really fantastic program that is aimed at high school students. It combines inquiry-based learning and problem-solving techniques to guide students through identifying a problem that they would like to solve, researching the issue, and then planning and executing a community impact project of their own design. And we've designed this program to be linked up with a Learning Enterprises Universal Learner Courses program. So high school students can actually earn ASU course credits for their Open Citizen projects. And this is a really great way that we're bringing a lot of the ideas and values of all of our learning programs here at Interplanetary to different audiences like high school students. We're currently piloting this program this fall and spring with 6 local high schools here in the Valley. We have about 300 high school students who will be going through the program. We're really excited to see how that goes. We have lots of supports in place for them, including professional development for teachers, as well as facilitation guides and various other software and things to support the program. So if you know any high school teachers, or if you have a high school student, or you know any principals in the area who are interested in learning more about this program, please have them reach out. It's a wonderful program that is a partnership between Interplanetary Initiative, Learning Enterprise, in collaboration with Beagle Learning. Thank you.
Thank you, Catherine, so much for walking us through all of those exciting programs. Please, yes, feel free to reach out to any of us to learn more, get involved. And without further ado, I'm going to introduce Joe Dubois and the team there at the Interplanetary Lab. Over to you, Joe. Joe is our chief engineer.
Thank you, Jessica. Yes, we're coming here live from the Interplanetary Laboratory on the Tempe campus of Arizona State University. With me, I have Sid, Jacqueline, and Dylan. There's 3 students that have been working, leading projects that the lab is working on, and you'll hear from them in just a moment. And then I'll talk a little bit about how to get involved. Next slide, please. So this is our current crew. The laboratory was really built to provide facilities to researchers that maybe they don't have for testing and for development of spaceflight hardware. And it's staffed by students who run the equipment, they have the procedures, they have the safety mechanisms in place. They also, and not as a byproduct, but as another core feature of the lab, is that they get hands-on experience. And what this is turned into, and if you would just select the slide, you'll see, if we go to the next, there we go, that of the 6 so far this year, and we're only in October, 4 of them have been hired. And I fully expect the other 2 will be hired within the next perhaps weeks. That's a good, I think that's a big statement for what the lab has allowed to happen. But you're going to hear even more as we go on. Next slide, please. Each of the transmissions, I talk a little bit about the capabilities, and the slide gets smaller and smaller because I want to highlight the projects that we're working on. But just to get everybody up to speed, we have what we're in right now is a collaboration area. We have several polycoms to have Zoom meetings. What you can't see is our ops center, which is off to my right, which has another half dozen students that are listening in. And we have an operations center, we have a ground station, we have antennas on the roof that can track spacecraft. We have an electronics lab that can develop everything. We'll order the boards to be fabbed outside, but then we'll populate them with the electronics parts. And then once they're populated, we can test them. We can put them in a vacuum and put them in a space simulation. We have an anechoic chamber to test antennas. We can do prototyping with the 3D printer and laser cutter and all kinds of fun toys, really. A new capability is this battery testing. Lithium ion batteries have to be qualified in order to fly. NASA requires that on any NASA flight. And the qualification involves a pretty rigorous set of tests. And historically, it's prohibitively or painfully expensive. But as a university, we can do this for our own projects. And if there's other universities, we'd love to cooperate with them and help them get over this hump. And finally, we have a clean room where we can assemble optics and other parts of spacecraft that might require a higher level of cleanliness. Next slide, please. A few of the projects and partners that we've been working on, and I'm going to talk a little more in a moment, but sort of from left to right, they're somewhat in order. Romer was a study, but it was a study that took all of our capabilities, and we brought in students. We brought in an extra, I think, dozen students to work on it, and it was to do a full system feasibility study. LightCube is a spacecraft that we launched this year, is in orbit right now. Dora is the next one up. We didn't sit around. We have that one. It'll be ready, and you'll hear more about Dora in just a moment from Sid. Dora will be integrated and tested in November, so in a month. Sparks is the next in line after that. We're mostly doing the environmental testing on that. You'll hear about Eclipse, which is a balloon flight. They're sort of in the middle. They did one balloon flight already, and there's another one next year. And then our future is in the hands of Coconut, which will be launching perhaps in a year, 2025. At the bottom there, we have Lunasonic, Celestial, Howe Industries. These are our local companies in Arizona that have their various levels of startup, but we have some facilities that they come and use and some expertise for this kind of environmental testing, which for spaceflight hardware, which otherwise they might not have access to, or it would be much more expensive. Next slide, please. So this gives you an idea of the timing. LightCube's launched. We have Dora, Sparks coming up. Everything's ongoing. One thing I hadn't talked about was the facility upgrades. We're upgrading some of our fabrication capability with a CNC and getting a mill from the ASU machine shop. They had a full mill that they weren't using that they're donating to us. Our vacuum chamber is good, but we want to upgrade it to reach higher vacuums and to have it a little more suited to the size and shape of spacecraft we're making. And then ADC testbed, this is a years-long project where this is the attitude determination and control system for spacecraft. So it's really going to allow to develop the control systems and have the feedback work correctly. You need to practice with it, and that means an air bearing, and it's pretty specialized equipment. And to devote the time to that, we haven't quite done it yet, but we have it in plans for this year. The reason we haven't is because we've had all these other projects that are above the line. Next slide, please. So with that, I'd like to introduce Sid Beatty, and he will discuss DORA.
Thank you, Joe. So this is DORA. DORA stands for Deployable Optical Receiver and Aperture, and this is a 3U CubeSat mission. So the goal of this mission is to measure radio background waves in lower Earth orbit and laser communications and demonstrate it. And we do this with two payloads that we're developing here. It's an optical payload for laser communications and a radio cosmology testbed, which maps low frequency and high frequency RF waves. Some of our partners for this mission consist of NASA, CSLI, which we got accepted in April of 2022, SSTP, JPL, and Vega Space Systems. And currently we are expected to deliver in November 2023, just shy of a couple weeks. Next slide. So in terms of Interplanetary's involvement in this project, we're in charge of doing custom PCB design for all of the flight stack components, the structure, manufacturing, and fabrication, as well as the design. As you can see on the picture to the right, we have the penthouse edition, which is that silver box on top. We also have the deployable antenna design, which is that black antenna that's sticking out above that silver box, and that is our main communications antenna for the satellite. We also do all of our software in-house. We have integration support, and we also do environmental testing where we simulate space-like environments within our thermal chamber and vibe fixture. Next slide. The current status for this project is we're currently developing some of the flight software, and it is on a flatsat test bed where we have all the flight stack components connected, and either the hardware is made in-house or we are expecting delivery imminently. And currently we're working on stacking the whole thing together and doing a final flight build with a chassis integrated, as well as all the components working, and doing a day in the life test with all the components turning on and simulating space-like environments. And then we're preparing to do environmental testing right after in November before our launch delivery. Next slide. Just to go over some of our team members and our current team for this project, it consists of our PI, who's Danny Jacobs, our co-I, Judd Mobin, and they're from the Low Frequency Cosmetology Lab, LOCO as you call it, and they've been great faculty members and staff that aid and abet in our current project, and they've also helped us with 5 current grad students and staff that help us in this project as well, that kind of help us develop our payload. And in terms of interplanetary personnel, excuse me, we have all 6 of the lab staff, and then we have 5 student contractors as well that are contracted to help with this project in various areas. That about wraps it up for me, but I'm going to pass it over to Jacqueline Doe, who's going to talk about Eclipse briefly. Thank you. Next slide.
Hi there. My name is Jacqueline Doe. I am the team lead for the Arizona Nationwide Eclipse Ballooning Project. So last year in August 2022, Dr. Thomas Sharp, who is the ASU NASA Space Grant Director, and I wrote a proposal which was later approved in December 2022. So our mission is to develop, integrate, test, and deploy 2 12-pound engineering track weather balloons coupled with system provided by NASA Science Mission Directorates and Montana State University for the Nationwide Eclipse Ballooning Project. As you see there in the pictures, that was on launch day last Saturday on October 14th for the annular eclipse event, where we were preparing the attachments for the balloon and the payloads itself. And after that, on the right side is when we start filling up the balloon, and that's when we launch around roughly about 9:30 a.m. Mountain Daylight Time saving. Next slide, please. So our team comprises of two sub-team. I'm currently leading the Arizona State University, which comprises of ASU student organizations, members from Society of Women Engineers, Women in Computer Science, National Society of Black Engineers, SDSL, SEDS, and more, and including University of Arizona, Casa Grande Union High School. The second sub-team is Embry-Riddle Aeronautical University. Again, they're leading the Phoenix College and also Glendale Community College. Next slide. And that is a picture of us last week on Saturday. Don't mind the alien in the background. I wasn't abducted by it, but don't worry, I got safely back into the hands of my team. But this again comprises of all the team members that were have been part of this adventure. Next slide, please. And then more information on all of our team members, all the names, including our roles and responsibilities. Next slide. So as I stated earlier, we did launch on October 14, 2023 in Roswell, New Mexico for the annular eclipse. We are anticipating to launch next year for the total solar eclipse on April 8, 2024 in Uvalde, Texas. Next slide, please. And this is a really cool phenomena that we retrieved these photos from the telescope, from the ground telescope, not from up air. This is the annular eclipse. As you can see, starting from the left is the contact one when it started to kind of transition over about 10:39. And then as you kind of move forward towards to the right side, you can see the totality happens around 10:41. So altogether, it's about a 2-minute totality. And of course, this is the time where for the annular eclipse, you do not want to stare at the sun and the moon itself. You will burn your eyes, but however, for the total eclipse, it's a total opposite. When the moon does cross over the sun, this is where you can actually take off your glasses and you can stare at it for 2 to 3 minutes. And after that, once the moon start moving away from the sun, then you would have to put your glasses back on. Next slide, please. And a lot of elements, a lot of events happen on both Friday the 13th, I know, spooky Friday the 13th, and October 14th. So kind of starting from the very left side is we did a lot of dress rehearsal. We set up our ground station and also our RFD 900 Yagi antenna, ensuring that all of our systems are working as intended to be. And with the dress rehearsal is I did have everyone to recite their roles and responsibilities. So we regurgitated several times. And then in addition, on October 13th, we did an outreach event at the Eastern New Mexico University. We spoke to high school students on our mission and all of our systems and payloads and how cool it is. And something I like to give away to students is enjoy engineering, enjoy the science about it. Don't be afraid to break things. That is the point where we go through several design iterations. And the day of the launch is not only we were preparing and tying our payload attachments and balloon, we also had a viewing party at the ISTB4, and where we had a great turnout of 900 participants on that day. And next slide, please. And feel free to pull up your phone right now. We do have an Instagram page. Don't mind me. There's an alien somewhere floating around there. But we would like to thank the Interplanetary Initiative Laboratory for allowing us to really develop, integrate, test, and store all of our systems. So again, thank you to the staff members. We truly appreciate it. Now I'm going to pass it on to Dylan Larson, who's going to be discussing more about the Coconut Project.
Thank you. I'm Dylan Larson. I'm a junior in computer systems engineering here at ASU, and I'm the lead of the Coconut CubeSat team. We are a part of the Sun Devil Satellite Lab student organization, which previously worked on the Phoenix CubeSat, and so this is our newest CubeSat project. We applied for the NASA CubeSat launch initiative, the same one that Dora got accepted to, and Phoenix, and I think the rest of our CubeSats here at ASU. We applied in fall of 2022. It was a student-written proposal. We had we were advised by faculty members here and SDSL, but we were awarded a CubeSat launch later in the year. by NASA. And so the next steps are to do a weather balloon flight we have that's coming up in a few weeks. And then the design reviews that NASA requests, and then hand off to NASA in 2025. And the next slide, please. And so what Coconut is it's a pretty simple project when it comes to CubeSats, because it's small, it's a 1U CubeSat, and it's really just focused on a LoRa radio, which is just a special kind of radio that allows us to do longer range data transfers. And so our goal with this project is to do a store and forward CubeSat where we can have small, inexpensive ground notes anywhere in the world. You can see on the image on the bottom right there. And our CubeSat can take information from any of these ground nodes and bring them back to ASU. And the goal is to have these be really cheap so research projects or other student groups can create their own. A big goal right alongside that is education, is to have people that are able to join the project, either making these ground nodes or working on this CubeSat. It's a student-led project. And so while we have advisors from faculty, it's all students building this project. And then lastly, for the Interplanetary lab is we want to test CubeSat hardware because CubeSat hardware off the shelf is really expensive. And so we're trying to make everything ourselves in-house. And then that should also assist with future CubeSat projects. And the Interplanetary lab also gives a lot back to us. Not only are they funding part of the project, but they also provide us with heritage components from Lightcube, even from Dora, and they have advising, so we get advising from the faculty members here, and then also test equipment and fabrication and all of the awesome things that they gave Lightcube. So yeah, and the next slide, please. And so our next goal right now is the weather balloon we have coming up in a few weeks. And so this is first and foremost just giving us a goal, giving us a milestone, and having the students be able to go out and do something with the project instead of just being in a lab working on it. And so it gives us a milestone, but it also lets us test our software and our electrical components. And we have a weather balloon structure that's similar to the CubeSat structure. And so we'll be able to test everything similar to how we might fly our actual CubeSat. And then the next slide, please. And then this is our team. And so me and Atul Kadancha are the team leads. We share that role. And then we also have Naman and Aniel, who also are subsystem leads, and then our entire list of members off there to the right, plus probably about 10 others that come in and out of the project. And with that, I'll give it back to Joe.
Thank you. Thanks to all of you. When we put it in black and white, the lab's been pretty busy. So I'd like to say that each week we have approximately 80 students in and out of the lab. There might be 25 on each of these two projects or each of these three projects, and then a few others that have smaller projects that come along. And that's all supported by a pretty small staff of 5 or 6 half-time students that manage each of the equipment. We have the 3 clubs. We also have faculty from CC, from Fulton Engineering, and of course from the Interplanetary Initiative. And we're always and Lance comes by once in a while too. So we don't have there's no exclusion there. Anybody can come from the school, but not just from the school. We also have the companies coming from outside. So this is I guess like the pitchfork that ASU has. It's 3 spears. If you're a student, come by the lab. We have open lab hours all 10 to 6 pretty much every day. If you're faculty, we can work with you. We can right now we're sort of in a season to find some new projects to get funded. We have a lot of good ideas. And if you're a company, local or otherwise, but local, it's certainly easier, come by and maybe we can work together and help you achieve your goals. And with that, our presentation is done, and I think it's handing back to Jessica.
Yeah, thanks so much, Joe. And thank you all for those great presentations. We do have a few questions, so for Joe and team.
Okay.
The first question is are there any opportunities for VLSI design? And this is from Sai Harika.
That's actually a very big maybe. I have a professor from the School of Engineering coming over that wants to next week. I haven't talked to her yet, Daphne Chen, and she wants to do in-space fabrication of chips like that. And so I think the best thing is if you're on campus, come by or email me, Joe Dubois at ASU. You'll find it. I'm the one. And we can start a conversation and see what we can do.
Awesome, thanks. There is one more question for you, Joe. And that is there latitude for collaboration with lithium-ion battery testing with researchers involved with LaSpace and PWEE Academy?
I'm not sure I know what that is, but I'm just gonna say let's talk. We'll see, because there's too many ways we can collaborate to put them on one piece of paper.
Great. So there is latitude. Answer is
Yeah,
yes.
there's latitude. Yes. I just need more info. Yeah.
You need more information. That's from Lisa Gethard. So please, yes, get in touch with Joe to explore further. But we'd love to collaborate more with LaSpace. I think that much is a yes. Wonderful. So I don't think there are any further questions in the chat or in the Q&A, but I want to thank everyone for joining us today and sticking around to the end and asking some great questions. Again, please be sure to subscribe to our newsletter to just stay in touch, and you can reach any of the folks that presented today. We really do look forward to hearing from you and also getting any feedback from today's presentation, what you liked, what you didn't like, what you'd like to hear more about. Please let us know. And hello, Rajani, I see here tuning in from somewhere in the world, maybe Brazil. It's really wonderful to have everyone tune in. Thank you all so much. And have a great rest of the day. Take care, everybody.